There we go. Now, the fact that it's dead last is not an invitation to not study. Okay? Prepare well. Ask good questions in the next 2 days, 3 days. Prepare well. You can do it. It's just a couple extra days to stick this thing out. The final is a written portion and a multiple choice portion, just like it was the last time. You have 2 exam review assignments. I'm giving you 10 points for each of them to give you 10% rather, of your final exam score as your exam review. So 20 points for the 2 assignments, 10 and 10. And then the rest of it, the other 190, will be split evenly between multiple choice section and written section. Looks just like last semester's final. One looks like your normal everyday test. One is multiple choice that you'll fill in on a Scantron, okay? I don't know where your final is. Actually, I could probably find, oh, look, I have the schedule sitting right here. Let's see. 4th period. You guys are in C31 with roads. So that's where you're going to go for your final. But here's what people always ask me. How do you study for math? Like, you can't study for math. You can study for math. And I'm going to tell you the best ways. I've done this for 17 years now. These are the best ways for you to study for your math, okay? Number 1, you need to take your time doing that entire review worksheet that I gave you and make sure you correct it. And make sure you ask questions when you don't understand it, because I literally laid out the final exam in front of me and I picked questions from the exam and I placed them on your exam review. So they're not the same question, but they're the same concepts. That does not, however, mean that every single thing on the final is on the exam review, but overarching concepts are on the review, okay? So if I gave you a sine problem, it might be that the one on the final is a cosine problem, but do you know how to use SOHCAHTOA, right? That idea. So the review worksheet is huge. If there is anything on the 1 through, 43, 44 problems that you don't know how to do, then you're not going to know how to do it on the final if you don't figure it out in the next couple days, okay? Because I promise it's on the final. Number 2, take all your old tests and quizzes and just try them again. If you didn't know how to do them then, like if you did something wrong then, fix it now. Because again, I made the final exam based on what I tested you on all semester. So chapter 7 through chapter 12, you should be able to take those tests again and do well on them. That's a lot of tests. You don't have to do it for every single test, every single quiz, but they're good practice problems. Okay, that's the type of problems you're going to see. And then this one is a huge non-negotiable. You must make a good index card, 4x6, because chapter 10 and chapter 11 and chapter 12 all had a boatload of formulas. And if you show up to the final without any of those formulas, good luck to you. It does not go well, okay? So please, 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 make a great index card. You may put practice problems on there. You may put all the formulas on there. You may duplicate your review worksheet. Write the whole review worksheet on there. I don't care. You may write whatever you want as long as it fits on a 4x6 and you writing it out by hand. Those are the requirements. Yes?
Will there be proofs on the final?
No proofs. And no constructions. Which is why my answer key looks a little different than the answer key that you would get. I used to have you do a rotation, and then we didn't. There's no constructions. Okay? Yeah.
Can we use both sides?
Both sides, front and back. It's good stuff. People always ask, do you have an index card that I can have? No, because I don't have enough for everyone, and I'm not going to play favorites. But if you want to trace an index card, this is a 4x6. You could trace it and then cut a piece of paper, or cardstock would be better. But if you want to do it on a piece of paper and just cut it out, that's fine. Just know that if you make it a 5x7, I'm going to rip whatever inch off that I want. So don't make it the wrong size. Questions on that? Yeah. I don't. Okay, here's the other thing. Fortunately, you guys are not the 8:30 block because that's the one that this tends to happen on, but I've heard a lot of you don't have the final block before mine, because it's integrated science and then like the history classes. So for those of you that don't have integrated science or a history class that you're taking a final in, you don't have a final before mine. Don't sleep in, okay? I don't want to show up to one of the classrooms and they're like, oh, Carson's not here. And then I have to call Carson at home and be like, Mrs. Wesley, Carson's not here. Oh, crap, he's still in bed. Bring him there. Like, we'll get him there. And then you don't get the full final exam time. So don't sleep in, okay? Don't wake up at 10 a.m. for a 10:30 final. That is just poor planning. Wake up at 9:30 so your body has a little more time to get accustomed to being awake. The other thing is don't plan on packing your bag in the morning because inevitably someone's going to oversleep and then they rush to school without a calculator, without a cheat sheet, and without pencils, and then start a final exam super stressed out, okay? Put your exam cheat sheet, your calculator, and some pencils in a backpack the night before. Have it sitting ready to go so that if by some slim chance you oversleep greatly, because it's 10:30, okay, you can grab your bag and run out the door, okay? And eat a good breakfast. And don't stay up till 3 a.m. studying. That is a bad use of your time. Study earlier in the day, study over the weekend, study ahead of time. But staying up till 3 and then waking up at 8 is a terrible idea, okay? So please don't do that. Okay. Any questions on any of that? Okay. I'm going to put up answers. I'm going to try to upload this video later. It's going to take a long time, so it's going to be a long video, but I'll see if I can get it done today. And then I'll just post it in the exam review. Okay. Another thing that gets done wrong a lot. Where is the y-axis? If I ask you to reflect over the y-axis, it's this one. Okay. So maybe on your thing, you just draw a teeny little coordinate plane with a y and an x so you don't mix them up. Or I was talking to Mr. Lever and just telling him, hey, just so you know, a lot of people mix this up on the final where they flip over the wrong thing. He said, X goes walking, right? X is this way. So as you like switch your fingers, they kind of look like little X's. Y goes flying. X goes walking. Y goes flying. And you make a Y, okay? So a little trick if you want a little trick to remember there. Am I going the wrong way? I'm going the wrong way. Okay. This one gets done wrong a lot because people see it and they think either SOHCAHTOA or they think it's a triangle and I'm finding the area, so it must be 1/2 base times height. Now you could do 1/2 base times height, but you'd have to come up with the formula on your own because you'd be treating this as your height and then you'd do SOHCAHTOA with that to find that missing piece. Remember, we found a formula. This is the area of an SAS triangle. And this is your formula, 1/2 BC sine A. Again, maybe you want to draw a picture where you say A is my angle and B and C are the two sides. Do something like that. Write the formula down. Look for an SAS triangle because it happens every time on this final that people don't know how to do that problem because they're so used to 1/2 base times height. If you have a triangle with SAS, you can use this formula and it's much easier. Okay? You can do 1/2 base times height, but if you do that, here's your height. Now you have to do trig, right, to find h, and then plug that into 1/2 base times height. This formula does all of that for you. Okay, this one, like half the people do wrong. Don't be one of the half. I ask you from a picture like this, and the picture looks oh so very similar to this. It is different numbers, but it's a circle, and we're looking for the length of an arc and the area of a sector, okay? Every time when I say, what is the arc length? People tell me 45 degrees. Is that an arc length? No, that's an arc what? Measure, okay? Arc length is this. I think it's the first question on your written portion. It is the very first thing you will answer. What is the arc length? Not 45. Plug it into this formula. What is the arc measure? Area of the sector? This formula. Plug it into the formula, okay? And I'll do that with you tomorrow if you have questions on it, because this was not part of what you had to do for today. Same thing with the SAS setup. But just so you're clear, you're gonna want to put those on your cheat sheet next to each other so that you can use them both, okay? And say, this is length, this is area of a sector. Label them for what they are. I think, yes, that was it. And then the rest of it, I will just, as we go through those questions, I'll tell you what to write down as well, or what I would write down. I'm not going to force you to write anything, but it would be a good idea. Yeah?
This review's due at 11:05 on Friday?
It's due before class on Friday, yes.
Can we just do 27 now, because I don't know.
Maybe at the end, but I want to make sure we get through what the questions were from today's first. Yeah. Okay. Did someone just say my name? No? Something else? Okay. Here we go. Number 4. Notice it says determine if, that is not a highlighter. Determine if the triangles are similar. If so, you need a similarity statement. This is a similarity statement, right? And then name the postulate or theorem. This is the postulate or theorem. If there are sides involved, then part of you doing that means you want a scale factor as well, okay? So take a look at number 4. You have a side here that corresponds to a side here. You have a side here that corresponds to a side here. And then you have right angle and right angle. So if you look at the flow of that, that's a side angle side that corresponds to a side angle side. But that does not mean they're necessarily similar. What do you have to check? The scale factor. Are they proportional, right? Does it match up with what we want it to? So 5 to 10 would have to equal 14 to 28. Does it? Yes, that is a 1 to 2 ratio, right? So if my scale factor is 1 to 2 for that, then I can say the triangles are similar, and here's how I named them, but this is not the only way to name them. Okay, I said WXU with UVT. You could say UXW with TUV. As long as the corresponding parts match up, there's lots of ways to name it. But that would be SAS similarity with a scale factor of 1 to 2. Okay. Okay, number 7. This was a tricky one. When you learned it in chapter 7, this one was hard. On the final, this one tends to be hard for some, not for all. But what you're going to do is you're going to set up similar triangles, okay? So if you take a look at this problem, you have, oh, all my fun colors went away. Let's bring them back. Okay, 3 different triangles that we talked about, right? We have the smallest triangle. We have the middle-sized triangle, the medium one. And we have the biggest triangle. Okay, so if you recall, we set this up so that we put all of our corresponding parts in the same spot, just to make it easier to set up a proportion. So I'm gonna redraw the smallest triangle is here. I always did it shorter leg vertical, longer leg horizontal. You don't have to do it that way, but that's the way I'm gonna do it right now. The middle triangle would be something like this. And then the biggest triangle, we'll put like that. All right, so take a look at the smallest triangle. What's your shorter leg on the small triangle, on this triangle? The 3 is the shorter leg, right? The longer leg is the Z. Just look for where the right angle is, right? One's shorter, one's longer coming off the right angle. And then the hypotenuse is always across from it. So that's a Y. Okay, look at your middle triangle, this one here. You have a shorter leg of Z. You have a longer leg of 12 and a hypotenuse of X. And then the big triangle. And this tends to be the one that gives the most trouble, I feel like. Here's your right angle. What's your shorter leg? The Y. What's your longer leg? The X. And then your hypotenuse. 15. You got to add those together. Okay, so if this is our setup, now it's a matter of just setting up a bunch of proportions. So where do you see X's? The medium-sized and the big, okay? You have a hypotenuse here, and you have a longer leg here. So if I want to set up a proportion, I need to match up with the longer leg here and the hypotenuse there, right? So it's going to be hypotenuse over hypotenuse equals longer leg over longer leg, right? So from pink to green, from pink to green. You want to keep going in the same order. What do? You cross multiply. So this is x squared equals 12 times 15 is 180. And then we square root. And these ones we always did in simplest radical form. I promise I will tell you on the final if I expect simplest radical. If I don't, then you're welcome to round. But on a problem like this, we typically did simplest radical form. What do you do from here?
You find a number that, like, a perfect number that goes into 180.
A perfect square, right? We need the perfect square. So this is something maybe you want to write on your cheat sheet. It's just the list of the perfect squares, so you don't have to think about it. They're just there. You're welcome to do this if you want. You don't need to, but it just kind of simplifies your life a little bit. Okay, those are all the perfect squares. So we're looking for 180 is divisible by which of those? Anyone know it? It's 36. So 36 times 5 means the square root of 36 times the square root of 5 is the square root of 180. And then you simplify that. The square root of 36 is 6. The square root of 5 we can't do anything with. So that's your x value. Which triangles are we going to use for y? The big and the small, right? You have a y here that would correspond on the big triangle to the 15. And you have a 3 up here that corresponds to a y down there. So if I go shorter leg over shorter leg, that's 3 over y equals hypotenuse over hypotenuse. Again, you're going to cross multiply. So you get y squared equals 45. What do you do next? Take the square root. So we're looking for a perfect square and a non-perfect square that 45 is divisible by. What's your perfect square? 9. So the square root of 9 times the square root of 5. The square root of 9 we can take, that's 3. The square root of 5 we cannot, so we just leave it as rad 5. And that'll be your y. which two triangles are you using for Z?
Probably the middle and
Small and middle. You have a Z here, so that can correspond to the 12. You have a 3 here that corresponds to this Z. So you'll go 3 over Z equals Z over 12. So Z squared equals 36, and take the square root. That one's a perfect square, so Z is 6. How'd we do? Got that? All right. Number 8. Anyone remember the name of this theorem that's being used here? What do you see? Two congruent angles. It's an angle bisector theorem, right? This bisects the angle. When we bisect the angle in a triangle like this, it makes the sides proportional with the pieces of the two triangles that we turned it into, okay? So I always say the two that are on the same line are the two that you're gonna put over top of each other. Kind of treat this as your like division bar. So we can say 16 over X, what's that gonna equal? 20 over 4. So you have to go, if I start on the triangle on the left, then I need to start on the triangle on the left again. Cross multiply that, you get 20x equals 64. Divide by 20. Is that 3.2? I believe. Yeah. Questions on that? All right. Take a look at number 9. We learned this one on the same day. We did the angle bisector theorem and the side splitter theorem, okay? This one also makes proportions in a triangle, but there's actually two different problems happening here. They're not both using the side splitter theorem. The one that uses the side splitter theorem is the X. Solving for the Y is a little bit different. So side splitter theorem says this: if I have parallel lines, then you can set up what it breaks it into proportionally. If you remember when I taught you this, this doesn't work great on this one, but I just extended these lines. So like this was my division bar here, and this was my division bar there, right? I could say 6 over 4 equals 12 minus x over x plus 3. Okay. So this will solve for x. What do you got to make sure of when you solve this? You're going to cross multiply. You need what? Parentheses. Yes. So this is going to be 6 times x plus 3 equals 4 times 12 minus x. Just be careful with distributing. A lot of people forget to distribute to every piece. Like this is 6x plus 18, and a bunch of people will say it's 6x plus 3. Not because you didn't know, just because you rushed. So take your time, distribute well. 6x plus 18 equals 48 minus 4x. Move that 4x over. Move that 18 over. And divide by 10. Okay, so that's how you get your x. Y is done a little bit differently because y is not splitting a side, right? It's not a piece of a side, it's an entire side of a triangle. So we need to work with entire sides of the triangle. Take a look at this. This y somehow relates in this big triangle to something in this small triangle. Okay, so treat it as two separate triangles. Y corresponds to what? To 9. Yeah, y over 9 should equal which full side of the pink triangle relates to a full side of the blue triangle? Not x plus 3, not 4. What's the full length of the side of the pink triangle? It's 10, right? So if I'm doing y is a full side over 9 is a full side, then I want to go 10 is a full side. That corresponds with the y over what?
4.
The 4. Okay, the full side of the smaller triangle. So you take that and you cross multiply. 4y equals 90. Divide by 4. I want to say that's 22.5. Yeah. Okay. Okay, here's something else I would put on your cheat sheet. Absolutely put this on your cheat sheet. We talked about two types of triangles. We talked about a 45, 45, 90. That was L, what was the third side? L rad 2, okay? Put that on your cheat sheet. Then we also talked about a 30, 60, 90. And then the 30, 60, 90, the shorter leg was L, the longer leg was L rad 3, and the hypotenuse was 2L. Good there? Okay, so let's see if we remember this shortcut. If I have this triangle, which is a 45, 45, 90, what do I do to a hypotenuse to get a leg?
You divide by 2 and multiply by...
Divide by 2, multiply by
rad 2.
rad 2. Okay, or you can do the math. That 18 is your L rad 2 side. Just solve for L. Divide by rad 2. That gets rid of this. And then to get the radical out of the denominator, we multiply by 1. 18 rad 2 over 2 is 9 rad 2. Okay, but you can always use that shortcut. And if you need to, write down the shortcut. Write down, if you have a whole number as the hypotenuse, divide by 2, multiply by rad 2. That's fine. Who is blowing me up right now? Huh?
And X and Y are both. I mean, yeah, that too.
9 rad 2, yeah, for both of those. Yeah.
So the rad 2's don't cancel each other out?
What rad 2s?
The 18 over rad 2 times rad 2 over rad 2. They don't like the top two.
This?
Cross multiply. Yeah.
I'm cross multiply, no. You cross multiply if you set things equal to each other. We're multiplying by this right now. So if you just multiply across, it's 18 rad 2 on top and rad 4 on the bottom, which is 2. Mm-hmm. All right, number 12, you are given a hypotenuse of 20. That's your 2L side. So if you just divide by 2, then L, which is the shorter leg over here, is going to be 10. Then your longer leg, if that's 10, and we want our L rad 3, that's going to be 10 rad 3.
How much work should we show for a problem? Like, do you
0. I don't need to see any work on a problem like that if you're going to use the shortcuts. Okay, something else to put on your cheat sheet. Oh, that was weird. So, toa. If that's not enough for you, write this. The sine is the opposite over the hypotenuse, right? The cosine is the adjacent over the hypotenuse. Like, you can write as much as you want. If this is enough for you to remember what SOHCAHTOA is, then great, just write SOHCAHTOA. But the world is your oyster. Write whatever you want. Okay, so look at number 13 here. SOHCAHTOA style. Where do you always start? At the angle. Okay, so you're going to start here. Which two sides do you have? The opposite is here. The hypotenuse is here. So which trig function? Sine. So it's the sine always of the angle equals opposite over hypotenuse. And how do you solve that?
Multiply both sides by 14.
Multiply both sides by the denominator. So you're going to plug this into your calculator. 14 sine 33. What do we get? 7.6. Oh my goodness. One moment, please. I need to turn off my haptics because apparently both sides of my family are going crazy right now. 7.6. Okay. Number 14. What is different about this problem?
The angle is
You're solving for an angle. What happens when you're solving for an angle? The inverse, right? Maybe you want to write that on your cheat sheet. If solving for the angle, you want inverse sine, inverse cosine, or inverse tangent. Do you remember how to plug that in? Second, right? Second sine, second cosine, second tangent. Okay? Okay, so this one, which trig function? Adjacent, and hypotenuse. So it's going to be the cosine of x equals 9 over 20. And then to solve that, you take the inverse cosine of 9 divided by 20. And what did it come out to? Like 63.3. How we doing? Do you need a little stretch break? Stand up, move around. You are welcome to, if you need to move. Okay. 15. Which trig function? This is tangent, right? From the angle, you have the opposite and you have the adjacent, okay? So we're going to say the tangent of the angle equals 6 over x. How do you solve it when your variable's in the denominator? Divide what by tan 63? Eventually. Right. Yeah, get the x out of there. Okay, so multiply by x, that gets rid of this. And then you divide by tan 68 and divide by tan 68. So this is what you're plugging in, 6 divided by tan 68. You get an x value of 2.4. Yeah. Four more, 5 more, 5 more. Okay, number 16. You have a right triangle. You know 2 of the sides of the right triangle, and you're looking for the third. Now, sometimes people get this mixed up with SOHCAHTOA. What's different between this and SOHCAHTOA? There's always what? There's some angle that comes into play, right? Not the 90, but some other angle. Either we don't know the angle, right? If there's a variable there, use SOHCAHTOA. If there's a number there and this is a variable, use SOHCAHTOA. But if it's 3 sides and that's all you're working with a 90-degree angle, it is Pythagorean theorem. A squared plus B squared equals C squared, okay? So we're going to do 4 squared plus x squared equals 18 squared. Now, hear me. Some of you on the test you just took set something up like this, and then you told me, after warning you so many times, that this is 14 squared. It's not. Don't do it. Okay? What do you do with this? You put it in your calculator, exactly how you see it. 18 squared minus 4 squared. Do not do what you think is the mental math and try to just subtract and then square. That's wrong. It doesn't work ever. Okay? Instead, type in 18 squared minus 4 squared equals, and it will do it for you, and it's fantastic. If you don't like that, then calculate what 18 squared is and calculate what 4 squared is. Please don't subtract their bases. Please don't. 18 squared minus 4 squared is 308. 14 squared is 196. Very different number, right? So there's my warning again. Let's see who heeds it. Be the one that heeds it. 308 is divisible by what? What?
4.
It is divisible by 4. So 4 and 77. 77 is not divisible by any perfect square. So this is 2 times the square root of 77. Okay. Okay, these next two are the ones that I said I would absolutely write down. Law of sines, and then the formula. Law of cosines, and then the formula. Notice you did not have to solve for y. Please don't mess with trying to solve for y. I didn't put any of those on there. Law of sines says you take your angle with the side across from it and call those A. And then you take your angle, a capital B, with the side across from it, a lowercase b, and you do the sine of A over A equals the sine of B over your B. Do you remember where people went the most off the rails on this problem? What came into play? A lot. You cross multiply, but you need parentheses in the right places, right? So if I cross multiply this, put the x out in front, x times the sine of 112, and then cross multiply this, 15 times the sine of 22. How do you solve for x? Divide by sine 112 on both sides. Okay, this goes away, but if you just plug that into your calculator, you'll get the wrong answer. Where do you need a parenthesis? After the 22, because your calculator is going to start one here. You have to finish it right there. Okay, so you plug that in, that will be your answer. Law of cosines. This is your capital A. Where's your lowercase a? Across from it. So this is your lowercase a, and then B and C are interchangeable. And you're just going to plug that into this formula. So it's x squared is your a squared. B squared plus C squared minus 2BC, and then the cosine of the angle. And that one you can plug straight into your calculator. You can say 81 squared plus 72 squared minus 2 times 81 times 72 times the cosine of 50, and you'll get this number, 4247.5253. The place you need to be careful is that's x squared. So then we need to square root both sides, and that comes out to 65.2. We're almost there. 2 more. Okay, this one. What is a translation? What's another word for a translation? A slide. Maybe you want to write that down. Translation is a slide. Reflection is a flip. Rotation is a turn. Did we do those? We didn't do any of those, did we? We did?
Yeah.
Rotations?
Yeah. But you said you're reading them.
We didn't, there is no like constructor rotation. I was trying to remember if we even did them. I thought we took them out. We did them. Okay. So all these things, you have the rule, a translation of -5, 1. Where does that move you? This is left 5, up 1, right? So from point K, I go 1, 2, 3, 4, 5 to the left, up 1. And then remember, K prime, right? The image, the new one, has the little hash mark. So you do that from every point, and you end up with this rectangle. Okay, so we just slid to a new spot. Okay, last one. You have to start these 3 points. This triangle. It says graph the triangle and its reflection image over the y-axis. Which one's the y-axis? The one that goes flying, right? This guy. So if I'm going to reflect there, it's 1, 2, 3 to the right. So I go 1, 2, 3 to the left. Same thing here. 1, 2, 3, 4 to the right. So 1, 2, 3, 4 to the left. Same thing for your n. And you get that picture.